In this lesson, we're going to look at modeling and solving two-step equations of a different form. So usually what you'll have is you'll have this value of a value A on the outside of brackets being multiplied using the distributive property by two values that are inside brackets, one of them being x, and x we usually denote as our variable, the value that we're trying to solve for. So now we have a value outside brackets being kind of acting upon this variable that's inside brackets in this way. So we're going to look at two methods on how to do this. We're going to look at the first one, which is dividing by the value in front of the brackets first to get rid of it, which may be your preferred method. Or secondly, using the distributive property and to multiply out that value in front of the brackets to expand it. So the first example we're going to look at is 2 times g plus 4, which is equal to negative 8. So we have this equation. We're going to solve it using method 1, which is dividing by the value in front of the brackets on both sides. Remember, we have to still balance the equation. So dividing by that value on both sides first, and then the method 2, which is using the distributive property to multiply everything out, to expand everything out, and then solve it that way. And we'll try to see, maybe you can see which way you like better. So first method, we're going to divide by 2 on both sides. So when I divide by 2 on the left-hand side, I still just cancel that 2 in the front. It equals 1, very similar to what we did before. So on the left-hand side, I'm left with, and I'm going to get rid of the brackets now because there's nothing acting upon the g plus 4 anymore. We're done. We've gotten rid of that 2 in the front, which is equal to negative 8 divided by 2, which is equal to negative 4. Now I'm back to a very simple one-step equation like we saw in the first lesson, the very first lesson. And for this one-step equation, I'm going to add 4 to both sides. Subtract 4. Because it's being added on the left-hand side, we have to subtract it in order to get rid of it. So I subtract 4, and I subtract 4. So on the left-hand side, I'm left with g, and on the right-hand side, negative 4 minus 4 is not 0. It is negative 8. Whoops, and I switched to red, but that's okay. So we have a value of g, which is equal to negative 8. Now, that's dividing by the value in front of the brackets. The second method is going to be distributing that value, that number in front of the brackets first into both values inside the brackets. So I'm going to multiply it out. So 2 times g is 2g, and then 2 times 4, 2 times 4 is 8. So I get 2g plus 8, which is equal to negative 8. Now, I'm left with one of these questions, these two-step questions where I have to either add or subtract first to get rid of the value on the left-hand side and keep going. So my first step is to subtract 8 on both sides. So that's going to get rid of the 8 on this side. It's going to leave me with negative 8 minus 8, which is negative 16, and 2g on the left-hand side. And then my final step is going to be to divide, because 2 times 2 is being multiplied by g, opposite operation, divide on both sides. So now I'm left with g, which is equal to negative 16 divided by 2, which is negative 8. So I get the same answer as I did on the left, just using a different method. So method 1, dividing by that value first. Method 2, multiplying everything out. It's totally up to you. So which method do you prefer? Personally, I don't really know. Depends on what the values of the equation are. Method 1 in this case worked out pretty easily. It looks like it maybe omits one step. So method 1 for me in this case works okay. But remember to always check your answer as well, right? So you can always take your value of negative 8, plug it back into the original question, replace that variable, right? So in this case, we'd have 2 times g was negative 8. So I replace g with negative 8 plus 4, which is equal to negative 8. We're going to check, right? We're checking to see if that's true. You can work out this. Now this time, because we have a value in, you would work out the brackets first, do your order of operations like normal. So negative 8 plus 4 is negative 4. We're multiplying that by 2, and we're checking to see if that does in fact equal negative 8. And of course it does. So it checks out, right? Because 2 times negative 4 is negative 8. Okay, let's do another one. So solve the following. 3 times r minus 7 equals 3. So method 1, we're going to take our equation r minus 7, and then, which is equal to 3. So the first thing we're going to do is we're going to divide out that 3 in front of the bracket. So dividing by 3 on both sides. On the left-hand side, of course, it cancels that 3. I'm left with just r minus 7, eliminating the brackets because nothing is acting upon the r minus 7 anymore. It's gone. And that's equal to 1 because 3 divided by 3 is 1. My last step is to add 7 on both sides because that's the opposite of subtracting 7, which gets me to r on the left-hand side is equal to 8. Okay, method 2 is going to be multiplying out the brackets using the distributive property first. So I'm going to take that value of 3, I'm going to multiply it in for r and for 7. So I end up getting 3r, 3 times r is 3r, 3 times negative 7 is negative 21, is equal to 3. I haven't multiplied anything on it, so I'm not doing, like on both sides, I'm not eliminating anything yet. I'm just using the distributive property. So you might run into a mistake of multiplying the other side by 3 at this first step, but that's not what we're doing. All we're doing is using the distributive property. My next step would be to eliminate the add or subtract first, right? Do the reverse order of operations. So add 21 on both sides. So that eliminates it there. I'm left with 3r is equal to 3 plus 21 is 24. And my last step is going to be division because this is 3 times r. We do the opposite operation. And that leaves us with r is equal to 8 again, which is what we had on the other side, but just, of course, the different way of doing it. Again, we can check that value. So we can plug 8 into the original question. So 3 bracket 8 minus 7. Does that equal 3? So 8 minus 7, of course, is 1 times 3. Does that equal 3? And we can say yes, so we've checked it. Okay, very simple to check. Let's do 2 more examples, and that's it, just to kind of work through these. So I'm just going to use method 1 because, you know what, I think method 1 is actually a bit easier than multiplying everything out. So the first step I'm going to do is I'm going to divide by negative 2 on both sides. So like we've seen before, cancels on the left-hand side. I'm left with x minus 3. Get rid of the brackets because nothing is acting upon them anymore. 12 divided by negative 2 is negative 6. Be very careful with your negatives and positives here because you can make little mistakes will change the answer completely. And then finally, adding 3 to both sides. Notice how there's nothing to divide this time. There's nothing in front of x, so that makes it a bit easier. So those 3's cancel. I'm left with x is equal to negative 6 plus 3 is negative 3. And that is my final answer. Number 3. Okay, oh great, the variable's on the right-hand side. No problem at all. We still just deal with it on the right-hand side. So I'm going to divide by 5 on both sides. On the left-hand side, negative 20 divided by 5 is negative 4. 5 divided by 5, those cancel. I'm left with 3 plus p. This is where you have to, again, look at the 3 and say, is it being added or subtracted? Well, because it's positive, it's being quote-unquote added. So to get rid of it, I subtract it. So I subtract 3 on both sides. And on the left-hand side, I get negative 7, which is equal to positive p. Now, that would change. If that was a negative p, we'd have to keep the negative sign there and eliminate it by dividing by a negative 1. But typically in this course, we don't really do that. And that's the final answer, p equals negative 7. And of course, you can go back and plug these values back into the original question to check to see if they're correct. Hopefully that makes sense for this lesson here. Just a matter of either dividing by that value in front or multiplying it out, and you can always check your answers as well. Thanks. Let me know if you have any questions at all.